There's a pattern physicists discovered decades ago that they still don't fully understand, and the disturbing part is that you're caught inside it right now. Every object in observable reality is rotating. Not most objects, not some objects. Every single one. From electrons smaller than you can imagine, to galaxy superclusters stretching across hundreds of millions of light years, nothing in the universe stands still. And here's what makes it unsettling. No one knows why. There's no law of physics that demands rotation. There's no equation that requires it. And yet it's everywhere, woven so deeply into the fabric of existence that without it, atoms wouldn't hold together, stars wouldn't form, and you wouldn't be here reading this. But the question isn't just why everything spins. The question is why we can't feel it. You're moving right now at over 1,000 miles per hour. That's not metaphor. The ground beneath you is rotating that fast, carrying your body in a silent circle that completes every 24 hours. At the same time, you're hurtling around the sun at 67,000 miles per hour, and the entire solar system races through the Milky Way at nearly 500,000 miles per hour. That's the speed of a bullet multiplied by thousands, and yet the coffee in your cup doesn't ripple. The air doesn't scream past your face. Your body feels nothing. This shouldn't be possible, and for most of human history, it seemed absurd to even suggest it. But the math doesn't lie, and the measurements confirm it. You are in violent motion, and you feel perfectly still. That contradiction is where this begins. Isaac Newton described the principle in the 17th century. An object in motion stays in motion unless something disrupts it. We call it inertia, and it's the only reason you're not ripped apart by the forces acting on your body right now. You don't feel the Earth spin because you're part of it. Your blood, your bones, the oxygen in your lungs, all of it moves in perfect synchronization with the ground. There's no difference in velocity, no friction, no signal to your nervous system that anything is happening. To feel motion, you need contrast. You need a push or a sudden stop. But the Earth's rotation has been constant for billions of years. It never accelerates. It never slows down enough for you to notice within a human lifetime. And so your senses, evolved to detect threats and changes, register nothing at all. You exist in the middle of cosmic chaos, and your brain interprets it as perfect calm. Astronauts experience this on an even stranger scale. When they orbit the planet at 17,000 miles per hour, circling the Earth every 90 minutes, they feel weightless. Not because there's no gravity, there's plenty of gravity. They feel weightless because they're in constant freefall and everything inside the spacecraft falls with them. Motion becomes indistinguishable from stillness when there's no resistance, no air, no friction. This is what physicists call uniform motion, and it's the same reason you can drink tea on an airplane traveling 500 miles per hour without spilling a drop. You and the plane are locked together in the same frame of reference, moving as one. Only when turbulence interrupts that smooth motion, only when something changes, do your senses wake up. That's the illusion we live inside. Stillness is just motion that hasn't been interrupted yet. But here's what most explanations leave out. The Earth's rotation isn't just some curiosity. It's what makes life possible. Without it, one side of the planet would bake under endless sunlight, while the other froze in permanent darkness. The spin generates a magnetic field that shields us from solar radiation that would otherwise strip away the atmosphere. The rotation defines day and night, seasons, weather patterns, ocean currents. If the Earth stops spinning and somehow you survive the immediate catastrophe, the world you'd wake up to wouldn't resemble anything you recognize. And yet none of this answers the deeper question. Why does the Earth spin in the first place? Why does everything spin? The answer isn't written in any fundamental law. It's written in history. When the solar system formed 4.5 billion years ago, it didn't begin as a collection of neat spheres floating in empty space. It began as a cloud. A massive, shapeless cloud of hydrogen and helium drifting through the galaxy. That cloud had motion. Not organized motion, just random turbulence. particles bumping into each other with no particular direction. But gravity doesn't care about randomness. Gravity pulls everything inward, and as the cloud collapsed, something interesting happened. Any tiny imbalance, any slight rotation in the original cloud got amplified. As the material shrank, it had to spin faster. This is conservation of angular momentum, the same principle that makes a figure skater spin faster when she pulls her arms in. The cloud became a disk, and at the center, the sun ignited. Around it, clumps of matter formed into planets, and each one inherited the spin of that original disk. The Earth's 24-hour rotation is a fossil. It's the leftover motion of a cloud that collapsed before continents existed, before oceans, before anything you'd recognize as a world. Now here's where it gets strange. That same process didn't just happen once, it's still happening. Right now, across the universe, clouds of gas are collapsing and forming stars, and every single one begins to spin. The James Webb Space Telescope has captured galaxies so distant their light has been traveling for over 13 billion years, and even those ancient galaxies show unmistakable signs of rotation. Scientists can detect it through something called redshift and blueshift. One side of the galaxy's light stretches toward the red end of the spectrum, and the other shifts toward blue. That's motion. That's spin. And it means that rotation isn't some quirk of our solar system or our galaxy. It's universal. The tendency to rotate is embedded in the structure of reality itself, and no one knows why. You can describe how it happens. You can measure it with extraordinary precision. But the question of why the universe has angular momentum at all, why it didn't begin in perfect stillness, that question has no answer. Not yet. There's a device that makes this visible in a way that's almost hypnotic. It's called a Foucault pendulum, named after the French physicist who first demonstrated it in 1851. It's just a weight on a long wire, free to swing in any direction. But if you let it swing and then wait, something eerie happens. Over the course of hours, the pendulum's path slowly rotates, even though nothing is pushing it. The floor beneath it is turning. The Earth is spinning, and the pendulum stays true to its original direction while the ground moves. It's one of the only ways to see the planet's rotation without leaving the surface, and if you've ever stood next to one in a museum, watching it drift across the floor, you've witnessed something profound. Time and motion merged into one silent proof. The Earth's spin is slowing, not by much, about 1.7 milliseconds per century, mostly because of the Moon's tidal pull. The same gravitational force that lifts the oceans also drags against the Earth's rotation, stealing tiny fractions of angular momentum and transferring them to the Moon's orbit. Which means the Moon is slowly drifting away from us, about 1.5 inches per year. Billions of years ago, the Earth spun faster and the Moon was closer, which means the days were shorter and the tides were stronger. In another few billion years, if the planet survives that long, the day might stretch to 25 or even 30 hours. But you won't be here to see it, neither will anything you recognize as human. What you're experiencing right now, this particular rotation, this exact rhythm of day and night, is temporary. A brief chapter in a process that started long before you and will continue long after. But the Earth is just one spinning object in a much larger pattern. The Sun rotates once every 27 days, dragging its magnetic field through space in a twisted spiral. The Milky Way galaxy turns once every 230 million years, carrying billions of stars in a structure so vast that light takes 100,000 years to cross from one edge to the other. And within that galaxy, every star system, every planet, every moon, all of them rotate. There are no exceptions. Even objects that seem chaotic, like asteroids tumbling through space, are still obeying the same conservation laws. They inherited angular momentum from the cloud they formed in, and that momentum never disappears. It just changes form, gets transferred, spreads out, but never vanishes. This is one of the deepest principles in physics. Angular momentum is conserved. It cannot be created or destroyed, which means every rotation in the universe today is connected to the rotation that existed at the beginning. Now we need to talk about something smaller. Much smaller, because rotation doesn't stop at planets and stars. It goes all the way down to atoms, and that's where things stop making intuitive sense. Electrons don't orbit the nucleus the way planets orbit the sun. That old model is wrong. Instead, they exist in probability clouds, regions where they might be found if you measure them, but they still have angular momentum. Physicists call it spin, and it's one of the most fundamental properties of matter. Electrons have spin 1/2, photons have spin 1, quarks, neutrinos, every particle in the Standard Model has a spin value, and without it, chemistry wouldn't exist. The way atoms bond, the way molecules form, the way your DNA holds together, all of it depends on the quantum spin of electrons. So when you ask why everything in the universe rotates, you're not just asking about planets, you're asking about the structure of matter itself. Here's what makes it unsettling. Quantum spin isn't literal spinning. An electron isn't a tiny ball rotating on an axis. If it were, the surface would have to move faster than the speed of light, which is impossible. Instead, spin is an intrinsic property, something particles have simply because they exist. It's woven into the mathematics of quantum mechanics, and no one knows why. You can measure it. You can predict it. You can use it to build technologies like MRI machines and quantum computers. But the question of what spin actually is, what it means for a particle to have angular momentum without physically rotating, that question has no satisfying answer. It's one of those places where the math works perfectly and the human intuition breaks down. And it gets stranger. Some cosmologists believe the universe itself might have a net angular momentum, not just the objects inside it, the entire structure of spacetime. There's a hypothesis that the early universe had a slight rotational bias, a preferred direction embedded in the fabric of reality. Evidence for this is controversial, but it shows up in subtle patterns in the cosmic microwave background, the faint afterglow of the Big Bang. The Planck satellite measured tiny temperature differences across the sky, and some researchers have interpreted those patterns as traces of primordial rotation. If that's true, it means the universe didn't begin in stillness. It began spinning, and everything since then has been a consequence of that original twist. Think about what that implies. If the universe started with angular momentum, where did it come from? The Big Bang is supposed to be the beginning, the point before which there is no before. But angular momentum doesn't appear from nothing. It has to come from somewhere, which means either the universe wasn't truly the beginning, or the laws of physics break down at that scale in ways we don't yet understand. This is one of those questions that sounds philosophical but is actually deeply physical. It touches on the nature of time, the origin of structure, the possibility of something existing before the Big Bang, and no one has a definitive answer. Let's come back to something you can feel: your body. Right now, your heart is beating. Your blood is circulating. Your neurons are firing in patterns that create what you experience as thought. All of that motion is built on the same principles we've been talking about. The electrical signals in your brain depend on charged particles moving through magnetic fields, and those fields only exist because of quantum spin. Your heartbeat is driven by muscle contractions, which are powered by chemical reactions, which are governed by the way electrons interact. And those electrons carry angular momentum inherited from the stars that forged them billions of years ago. You are made of rotating matter, and every process that keeps you alive is a continuation of the motion that began at the start of the universe. You're not separate from this pattern. You are the pattern, expressed in a temporary form. There's a concept in physics called frame dragging. It was predicted by Einstein's general relativity and confirmed by NASA's Gravity Probe B experiment in 2011. The idea is that massive rotating objects don't just sit in spacetime. They twist it. The Earth's rotation drags the fabric of spacetime around with it, like a spoon stirring honey. The effect is tiny, almost unmeasurable, but it's real. And it means that spin isn't confined to objects. It extends into the geometry of reality itself. Every rotating mass warps the space around it, leaving a trace, a distortion that propagates outward. In a sense, motion is written into the structure of the cosmos. It's not something that happens in space, It's something that shapes space. Now imagine this on a larger scale. Black holes, the most extreme objects in the universe, rotate at incredible speeds. Some spin so fast that their event horizons are stretched into oblate shapes, bulging at the equator. The angular momentum of a black hole is so intense that it drags space-time into a violent whirlpool, creating a region called the ergosphere where nothing can remain still. Even light is forced to rotate. And when two black holes collide, they don't just merge. They twist together, creating gravitational waves that ripple across the universe at the speed of light. Those waves carry information about the spin of the original black holes, and detectors like LIGO can measure them. We're now listening to the rotational history of objects that collided billions of years ago, decoding their spin through the vibrations they left in spacetime. Here's what no one tells you. Rotation might be the closest thing the universe has to memory. Not memory in the human sense, not consciousness or emotion, but physical continuity. Every spin leaves a trace. Every rotation warps spacetime, encodes information, passes momentum to other objects. The cosmic microwave background, the light from the Big Bang, carries polarization patterns that act as a record of the universe's earliest rotations. The light you see from distant stars is twisted by the motion of galaxies it passed through on its way to your eyes. Even the spin of particles inside your body is linked to the quantum states of atoms that formed in the cores of ancient stars. In a purely physical sense, the universe remembers its motion, not as thought, but as structure, not as awareness, but as continuity. There's a question that emerges from this, and it's one that science can't fully answer yet. If rotation is universal, if it's embedded in the structure of matter and space-time, if it's been present since the beginning and will persist until the end, then what happens when motion stops? The second law of thermodynamics tells us that entropy always increases. Energy spreads out, heat dissipates, and eventually, in trillions of years, the universe will reach a state called heat death. Stars will burn out, black holes will evaporate, matter will decay into radiation, and in that final cold, dark state, will anything still be spinning? The answer, strangely, is yes. Even in a universe of maximum entropy, angular momentum will still be conserved. It won't disappear. It will just be spread so thin, encoded in such low energy states, that nothing will interact anymore. The rotation will still be there, written into the geometry of spacetime, but there will be no observers, no structure, no way to measure it. The universe will spin in silence forever. But we're not there yet. Right now, the universe is full of motion, full of structure, full of objects that still carry the momentum of their creation. And you're one of them. The atoms in your body were forged in stars that exploded billions of years ago, and when those stars collapsed, they spun faster and faster, reaching speeds that would tear apart anything we've ever built. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, all of it passed through that crucible of rotation. And when those stars died, they scattered their material into space, where it drifted for millions of years until gravity pulled it together again into a new cloud, a new disk, a new solar system. Your body is made of recycled stars, and the spin those stars carried is still inside you. There's one more thing, and it's the part that connects everything we've talked about. If motion is the universe's form of memory, if rotation is the pattern that links the largest structures to the smallest particles, then what does that make consciousness? Not in a mystical sense, in a purely physical sense. Your awareness right now is the result of neurons firing, of electrical signals propagating through your brain, of chemical reactions driven by quantum interactions. All of that is motion. All of that is built on the same angular momentum that spins galaxies. You are not observing the universe from the outside. You are the universe observing itself, a brief configuration of rotating matter that has become complex enough to recognize its own existence. And when your body stops, when the motion that defines you disperses back into the environment, it won't be gone. It will just change form. The atoms that make you will drift apart, join other structures, continue spinning in new patterns. The universe doesn't lose information, it redistributes it. So when you ask why everything in the universe is spinning, you're really asking why existence has structure at all. Why there's organization instead of chaos, patterns instead of randomness, form instead of void. And the answer seems to be that motion is the only way structure can persist. Without rotation, gravity would collapse everything into static points. Without angular momentum, atoms couldn't exist. Without spin, there would be no chemistry, no planets, no stars, no life. The universe spins because if it didn't, there would be nothing. Not even nothing. Just an undefined state with no way to measure it, no way to describe it, no way for anything to happen. Motion is existence. Stillness is not peace. It's the absence of reality itself. And yet, you feel still. Sitting there, reading this, your body perceives itself as motionless. That perception is not wrong, it's just local. From your frame of reference, you are at rest, and the universe moves around you. From another perspective, you're hurtling through space faster than any human technology can replicate. Both are true. Reality doesn't have a preferred frame. There's no absolute stillness, no fixed point in the cosmos to measure against. Everything is relative, and motion only has meaning in relation to something else, which means the stillness you feel right now is as real as the motion you can't perceive. They're two descriptions of the same thing, two ways of framing the same physical state. And that duality, that tension between motion and calm, is woven into the deepest structure of the universe. There's a prediction Einstein made that hasn't been fully tested yet. If the universe itself is rotating, there would be subtle asymmetries in the distribution of galaxies, slight preferences in the orientation of galaxy spins. Some surveys have hinted at this, but the evidence is still controversial. If it's confirmed, it would mean that even the largest structures in existence are part of a single, unified rotation. The universe wouldn't just contain spinning objects. It would be a spinning object, and that raises a question no one has seriously attempted to answer. If the universe as a whole is rotating, what is it rotating relative to? There's nothing outside the universe by definition. So rotation would have to be an intrinsic property of spacetime itself, woven into the geometry of reality without needing an external reference. That concept breaks most of our intuitions about motion, and it suggests that the rules we understand might be incomplete. Here's what keeps physicists awake at night. We can describe rotation. We can measure it. We can trace its origins back to the collapse of primordial gas clouds, to the conservation of angular momentum, to the quantum spin of particles. But none of that explains why angular momentum exists in the first place. Why does the universe have this property? Why is it conserved? What would a universe without rotation even look like? And why isn't that the universe we inhabit? These aren't questions with answers yet. They're not even questions with clear paths toward answers. They sit at the boundary between physics and philosophy, in that uncomfortable space where the math works, but the meaning dissolves. And maybe that's the point. Maybe the universe doesn't spin for a reason. Maybe it just spins because the alternative, perfect stillness, is physically impossible. Maybe motion is the default state, and stillness is the illusion we constructed to make sense of our own existence. Because if everything is always moving, if there's no fixed point, no absolute rest, then the only way to navigate reality is to pretend there's a center, to place yourself at the origin and measure everything else relative to you. That's what consciousness does. It creates a frame of reference. It turns the chaos of motion into a coherent experience. And in doing so, it gives the universe a way to observe itself. Not as a collection of isolated spinning objects, but as a single, interconnected system where every rotation affects every other, where motion at one scale shapes structure at another, where the spin of a galaxy and the spin of an electron are part of the same unbroken pattern. You are part of that pattern. Not metaphorically, physically. The motion that defines you began before stars existed, and it will continue long after you're gone. The stillness you feel is temporary. The rotation is eternal. And somewhere in that tension, in that paradox of feeling motionless while hurtling through space, is the closest thing we have to understanding what it means to exist at all. Because existence isn't a state, it's a process. It's motion that never stops, structure that never settles, a universe that spins because stopping would mean ceasing to be. And there's a deeper implication here, one that doesn't get discussed enough. If consciousness is a byproduct of motion, if awareness emerges from the complex interactions of rotating matter, then the universe isn't just spinning, it's waking up. Not everywhere, not all at once, but in pockets, in rare configurations where matter becomes organized enough to reflect on its own existence. You're one of those pockets. A temporary arrangement of atoms that inherited the spin of dead stars and used it to build a brain capable of asking why. And when you look up at the night sky, when you see the faint glow of distant galaxies, you're seeing other configurations of rotating matter, other structures shaped by the same principles that shaped you. Some of them might be asking the same questions. Some of them might have found answers we haven't. And some of them might have realized that the question itself is the answer, that the reason everything spins is because spinning is what the universe does, and understanding that is as close as we'll ever get to understanding why we're here. But there's still something missing, something we haven't touched. If motion is universal, if rotation is the pattern that connects everything, then there should be traces of it we haven't found yet. Signatures in the structure of spacetime that reveal a deeper layer of organization. Some physicists are looking for those traces in the polarization of light from the cosmic microwave background. Others are searching for asymmetries in the distribution of matter at the larger scales. And a few are exploring whether the spin of particles might be connected to higher dimensional geometry, structures that exist beyond the 3 dimensions of space we perceive. If any of that is true, if rotation is a shadow of something more fundamental, then everything we've talked about is just the surface. The real question isn't why everything spins. It's what the spinning is trying to tell us.